Everyone, this is Om Singh Pawar with Preksha Bhandari and Nitisha Goyal, and we have made a classic snake game using data structures for our I project. Giving some introduction on it, this project is a simple console based implementation of the classic snake game written in C programming language. In this game, the player controls a snake on a fixed gaming grid, directing it toward a randomly placed fruit. Each time the snake consumes a fruit, it grows longer, and the game continues until the snake collides with the wall or itself. The game is designed to be played in a terminal environment using keyboard inputs to change the direction of the snake. We were inspired by the use of C language and data structures in a recreational space of video game. This program demonstrates the basic game logic, keyboard input handling, and real time gameplay mechanics. Moving on to the problem statement, the objective of this project is to create an interactive and simple version of the snake game where the snake grows with each fruit it consumes. The game should end if the snake collides with the grid boundaries or itself. The player should be able to control the snake using the keyboards respectively. Additionally, the game must display the game board, snake, and fruit accurately in the console. The main data structures were used in this project was array. The primary data structure used was a struct called snake. The snake struct encapsulates all the data related to the snake, including its body, position, and length. These arrays store the position of each segment of the snake's body. The X array holds the X coordinates, and the Y array holds the Y coordinates for each body part. Each element in this array corresponds to a part of the snake, where X0 and Y0 represent the head of the snake, and X length and Y length represent the last segment. These arrays are updated continuously during gameplay to reflect the snake's movement across the board. When the snake moves, the head's position is updated first based on the direction input, and then each subsequent body segment follows the position of the segment in front of it. The variable snake tail length keeps track of how long the snake currently is. Each time the snake eats a fruit, the length increases by 1, representing the snake's growth. The snake tail length is critical for managing the body segments in the X and Y arrays. By knowing the current snake tail length, the game logic can determine where the body ends, which is essential for updating the position of each segment correctly and managing the game's boundaries. Now I will pass on to Nitisha, who will demonstrate the code and explain its working.
So this is the code for the PS project. We have imported all the necessary libraries. We have defined the height and width of the grid in which the game is going to be in. We have the snaketail X and snaketail Y, which are two arrays for the body of the snake. And then we have the rest of the global variables. We have the setup function, which basically initializes the game, placing the head of the snake in the middle of the grid and then randomizing the fruit X and fruit Y variable so the fruit can appear anywhere. And then it also sets the score and the length of the snake tail to 0. So when the game begins. The draw function is used to draw the walls, the fruits, and everything on the grid. We hash symbol is for the walls, asterisk is for the fruits, capital O for head, and small o for tail. Then we have the input function. Here the kbitch ID function is used to see if a key is pressed, and the getch function is used to retrieve the key. So the input function reads the values of basically waits for the key to be pressed and takes input from the user. Then we have the logic function. So the logic function here updates the coordinates of the snake's body corresponding to the key which is pressed by the user. Then it also has conditions for the wall collision and the self collision. Self collision happens when the snake's head collides, overlaps with the coordinates of the snake's tail, and then if the snake's coordinates of the snake's head collide with the overlaps with the coordinates of the fruit's coordinates, then the snake tail length is increased and the score is also increased by 10, and the fruit x and fruit y variables are randomized again. And then we have the main function. So the main function calls the setup function that enters into a while loop. Then draw input logic functions are called, which we have defined above. Then this is the demonstration of the code. So the wall collision has happened, so we have entered the game. Now I can press X to exit the game. Now I'll be passing the presentation over to Preksha so that she can talk about the further scope and the conclusion of the project.
What do we learn? Memory management. C does not have automatic memory management as other higher level languages. So this project gives you practice with efficient memory use, such as fixed size arrays for tracking snake positions. Second, real-time input handling. It utilizes non-blocking input to enable gamers to enjoy smooth and responsive games in real time, which is quite important in most applications like games and embedded systems. Real-time input handling makes it possible for continuous flow of gameplay that is essential for response. Third, basis for more complex games. Once you understand the core mechanics, this snake game can serve as a starting point for more complex games like adding levels, scoring, speed variations, or obstacles. Fourth, logical debugging. Issues such as boundary and self collision or handling non blocking input provide valuable practice in debugging logical and runtime error. The flowchart. Start. The game begins. This is the entry point where initial setup occurs before the game starts. Initialize snake and game. This is the setup, the initial game environment, including the starting position and direction of the snake, the game grid, and any initial parameters like the score and speed. Third, main game loop. Enter the main loop where the game runs continuously until a game over condition is met. The loop manages the game's ongoing events and objects. Fourth comes the display game state and draw the game grid. It like the current state of the game on the screen showing the game boundaries and the food item. Fifth, check player input and change direction accordingly. Basically, it checks for an input from the player, that is the usage of the arrow keys to control the snake's direction. If an input is received, it adjusts the snake's movement. Sixth, this it checks if the snake has collided with itself or the game boundaries or like the wall collision. If there is a collision, the game which the game will end. If not, the game continues. Seventh is continue if no self or wall collision or lose if collision is based on the collision assessment. If there is no collision, the game loop continues. If there is collision, it, the game exits. The game is over. Lastly, game over and display score. When collision occurs, the game ends. The final score is displayed, showing the player's progress in the game. Algorithm. First, initialization. Set up the snake structure for body coordinates and length. Feed the random number generator and initialize snake position, center of the grid. Randomly place the first fruit within the grid. Second, the main game loop. First, draw game state. Create the console and draw the game grid, including wall, snake, and fruit. Second, input handling. Check for key presses using KB hit. Update snake direction based on input. Keys used for movements are WASD and X to exit the game. Third, update snake position. Move the snake's head in the correct direction and store the previous head position. Fourth, check for fruit collision. If the snake's head overlaps with the fruit, increase length and reposition the fruit. Fifth, move snake body. Shift each segment of the snake's body to follow the head. Sixth is collision detection. Check if the snake hits the wall or itself. If it if there is collision, exit the game. Seven, delay. Use a sleep for game speed control. And then game over. Display a game over message and exit the program. Conclusion. The Snake Game project demonstrates some basic programming concepts such as data structures, real-time handling of input, and logic implementation. Using a simple yet engaging game, the project takes care of managing user input in game states, updating collisions, and ensuring smooth gameplay. This would be the choice of C as the programming language for the game. Since it is important to have low level control in game development, this is because low level control can be efficient for performance and resource management. This project is an excellent foundation for understanding game development principles and can be expanded to include more complex features and mechanics. Scope of the project. This project can be extended with graphical libraries like SDL or OpenGL, giving experience with 2D game development and graphical programming concepts. The project can also serve as a stepping stone for exploring advanced topics such as artificial intelligence, where AI controlled snakes can compete against the player, or using frameworks like SDL or OpenGL for more graphical rendering. Thank you for listening to us.